Hi, this is Brianna, and today I am going to be walking you through my analog vinyl, which is an electric violin synthesizer. So, let's get right to it. I'm going to first show you how I built this, and we're just going to take a look right inside, and then I'm going to play something for you. So, everything in this circuit, while it looks very complicated, can be divided into pretty much about 3 parts. Number 1 is the primary oscillator, which you see in this section here, along with all of these keys over here. Then there's a section that deals with LFO and vibrato, which is over here. And then finally, there's a section for amplification and output. So let's go over the first section first. This section is all primary oscillators, and so I have a dual oscillator that can alternate between a square wave and a triangle wave. Between these oscillators, I have 8 different keys that can be played, and those are all controlled by these potentiometers over here. And you can see where these connections are with all these vertical wires. Another thing about this is that you'll notice that usually in order to trigger a note, you would need something like a push button or something of that nature. But my approach to this synthesizer was a little bit different, mainly because I felt that a lot of synthesizers already use push buttons or some other mechanism that resembles a piano or a keyboard, and I want to try an approach that was a little bit different. So here's what I came up with. If you're familiar with how a stylophone works, they work by breaking the circuit in the oscillator and then rejoining that circuit with a metal stylus touched to usually some sort of metal plate, and that's what creates a note. So I was inspired by that idea, and I decided, why not use, instead of a stylus and metal plate, these exposed metal wires, which are going to resemble my violin strings, and then my very own conductive violin bow. And basically how I made this is I basically took a piece of conductive thread and I wound it really tightly on a wooden chopstick, and it's held in place with a little needle as well so that it's nice and tight. And this is my playing mechanism, and you'll see that this is actually connected through this conductive string right to where the circuit was broken. And when I touch my violin bow to any of these strings, it'll complete the circuit and create a noise, and it'll create them in whatever note these are tuned to. So right now I have it tuned to roughly a G major scale, and of course the intonation is not perfect because these analog oscillators tend to fall out of tune very quickly, but this is a rough idea of what it sounds like. So just like that. And I'm going to show it again with the other type of wave we have here as well. Because remember, this is a triangle and square oscillator, so you can actually switch between 2 different options. Here's the square. And you can imagine in a more complete version, of course this is just a prototype, but you can imagine if you had like a nice isolated string that you would be able to play this with a very similar motion to playing an actual violin by moving the string of the bow horizontally, and that would, as a really, I think, nice departure from the typical layout so of a stylophone or any sort of analog synth. So imagine you can move it horizontally like this, try to get a better angle. And so you could play in that sense. Now, there's another thing that I felt was missing from this violin-inspired synthesizer, and of course that's the vibrato, because that's really the signature sound of the violin. So I thought, how could I recreate that? And so I decided to make a vibrato circuit. So the vibrato circuit can be controlled by 2 different parameters. Number 1 is it can be controlled by the width of the vibrato, so how much it's deviating from the actual note, and it can also be controlled by the speed of the vibrato, or like how fast that oscillation of pitch is happening. So you'll see that there's a blinking blue light, and that's actually showing what's going on inside the Vactrol right now. And the Vactrol is that little black thing right there, and that's just an LED light taped to a photocell. And so if I turn this knob, I can adjust the brightness of the light. You can see it's getting brighter, 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 or it's getting dimmer and dimmer. And that's controlling the width of the vibrato, because whatever the photocell is receiving from that light, that's adding extra resistance to the note you already have. And changing the resistance more drastically obviously is going to create a wider vibrato. But there's also another parameter by which we can change this vibrato, and that's actually the speed. And the way I control the speed on this is using this soft potentiometer. And the really neat thing about this is that you can use it in a very similar way to the hand motion that is used for actual vibrato on a violin. And if you're familiar, it usually comes from your wrist and you're moving a single finger. And so that can be done very similarly here, where you move horizontally and you can actually change the vibrato over time by doing this, which makes a lot of very interesting sounds possible. So I'm going to demonstrate what that would sound like. And by the way, I do have a switch for this as well. And that's like my vibrato on and off switch. So if you just want a clean sound, you can turn it off. And if you want that vibrato sound and you want a little bit of something different, you can also choose vibrato. So here's what it sounds like with a vibrato. Here, I'm just gonna try to... So that's a single note. And I'm gonna rest this here, and I want you to hear how it changes when I touch the soft pot in different places. You hear it's almost becoming like an FM signal. So you notice when I pinch it up like really high up here, this LED is blinking so fast it almost doesn't look like it's moving. And similarly, the vibrato becomes so fast you don't even hear it moving, it just sounds like a single noise. So it's almost like an FM synthesis kind of sound, and it's maybe not typical of a violin, but it's a really cool way to alter your sound on this instrument. So that's enough of that. And so that's just one of many ways you can kind of experiment with this instrument. And the last thing I want to focus on is the output section of this instrument. And I really wanted to be able to make a self-contained instrument. So I thought, how can I do that? And I thought of no better solution than to put a speaker right into the instrument. In order to do that, first what I did is I took my audio signal and I sent it to a switchable audio jack out. So you'll notice if I look on the side here, I have a little box there, and that's actually an audio out. So you can plug in headphones to that and listen on headphones, but let's say you don't want to do that. Well, if in the case that you don't have headphones plugged in, it won't switch to the headphone pins on the audio jack. And instead what will happen is you will get output sent to the speaker. Unfortunately, you cannot just send audio right to a speaker. It has to be amplified first because it's not loud enough on its own. So I used a very simple circuit using an LM386 chip, which you see here where that giant capacitor is, and that's just a very simple circuit to amplify our signal.